Now we're done with the required topics for this topic, which is on the universal law of gravitation and weight. So we already have solved some problems involving universal law of gravitation. So possibly lalabas sa FQ or sa exam yung calculations na yan. So please pakiaral yon. But now let's focus on the question of bakit kaya ba 1/r² ang universal law of gravitation? Yun yung tanong eh. Bakit naisip ni Newton na 1/r² ang gravitational force? Okay, so first we will discuss Kepler's laws, and then after that we will relate Kepler's law with our with how Newton obtained his analysis on circular motion or radial motion, and then after that you will find out that ganun lang pala yung nangyari. Okay, and then after that we will see some historical perspective and philosophical perspective of Newtonian mechanics, and this will be the coverage of the supplementary discussion, which is on Kepler's laws and Newtonian synthesis. Okay. So you have Johannes Kepler. Johannes Kepler is one of those astronomers, maybe about a century before Newton. So importante siya because he formulated his Kepler's law of planetary motion. So from the observations of another scientist named Tycho Brahe, he used that data to obtain some conclusions about the motion of planets around the sun and the motion of other bodies around other planets. So he studied the motion of planets around the sun, and of course, one can show that the three laws of planetary motion can be derived from Newton's universal law of gravitation. In fact, Newton did the reverse. From the three laws of planetary motion, in particular the third law of planetary motion, you will get the Newton's universal law of gravitation. Okay. He was also, according to at least the slides, he was the first to coin the term satellite or star wanderer atang ibig sabihin. I'm not sure. Paki-check. Okay. So and from there we have your three laws of planetary motion. So the motion of planets around the sun is governed by three empirical laws. This is an empirical law, therefore it should be based on just observation and experimentation. Hindi yan galing sa theory. So, in a way, para siyang phenomenological principle. So, kasi nanggaling ka sa observations and then you formulated a theory. Okay, at this point on planets, tama to. Okay? So, yun yung basis ng planetary motion. So, the first law states that all planets move in elliptical orbits at the sun at one focus. So, the keyword here, it is moving elliptically. Okay? But for planets, except for Pluto, di na pala planet si Pluto, noong 2006 pa dineclare yun, medyo maliit ang eccentricities ng mga planets. Kaya, to a good approximation, kung medyo rough calculations lang yung kailangan mo, pwede mo siyang gamitan ng circular orbit approximation. Pero, in general, hindi siya ganun kasi ka-accurate. Medyo to a good accuracy, pwedeng circular, pero kung gusto mo mas accurate, you need to consider the eccentricity or the oblateness of the orbit. Okay. Then the second law states that a line joining any plane to the sun sweeps out equal areas in equal time. So you have this definition called the areal velocity. You can calculate the areal velocity using conservation of angular momentum and show that at any given point in the orbit, if you trace that, if you trace an area of that orbit, you will calculate equal areas in equal times. And then finally, your third law, the square of the period of any planet is proportional to the cube of the planet's mean distance from the sun. The third law is the most important for us today. Okay, let me just reiterate these three laws of planetary motion. So the third law states that t squared equals CR cubed. I'll explain more on that as we go along. So the first law is on the ellipse. So, an ellipse, basically, ang sinasabi dyan, if you have two foci, which define the ellipse, if you trace a line joining one foci and a point on the ellipse, and then you trace another point, another line from the second foci towards the same point as of the first foci, and then you add the distances of these two, they're always constant regardless kung nasaan yung point. Basta yung point na yun nasa ellipse. So, yun yung actual more geometric definition ng ellipse. Okay? So, okay. Now, usually, ang nangyayari, the sun is located at one of the foci. Di pala usual. Talagang dun siya nakalocate. The sun is located at one of the foci. Tapos, if the planet is nearest compared to the sun, if the planet is located at the distance nearest to the sun, or nearest from the sun, then you have your so-called perihelion. And if the distance between the sun and the planet is the farthest, then you have your aphelion. Okay, in general, hindi kailangang sun yon. Kapag hindi sun ang nag-orbit, depende. Pero in general, it's periapsis and apoapsis. If there's an arbitrary heavenly body circling another arbitrary heavenly body, you have your periapsis and your apoapsis. Again, the perihelion is the point that's closest to the sun, and the aphelion, on the other hand, is the point farthest from the sun. So that's your Kepler's law. Kepler's first law. Sinasabi lang niya na elliptical ang orbits ng mga planets. Okay, as to why it's elliptical, it has something to do with the total energy on the total energy of the planet, which we will not discuss in this course for now. Okay, and then for the second one, so using conservation of angular momentum, what can show that the total area swept by this region here, so therefore this planetary some velocity v1 is also equal to the total distance or total area that is swept by this planet at another region. At any given region, pare-pares lang yung area niyan, with the assumption na equal ang times na trinaverse ng planet at the two different regions. Okay? So that can be shown using conservation of angular momentum. We will not show it here anymore. So the planet tends to move faster at the perihelion kasi mas malapit siya sa sun. Therefore, dapat, in-expect ko na dapat na mas mabilis siya kasi mas malapit siya, MVR, sin theta. Now, pag mas malayo siya, dapat mas mabagal din siya. Planet tends to move slower at the aphelion, which is the farthest point from the sun. Okay? So, ganun yung nangyayari. And it turns out that when you compute that area, it should be the same due to conservation of angular momentum. Okay, that's basically conservation of angular momentum. And then finally, this is the most important for our discussion today, Kepler's third law, which is on law of periods. The periods of the planets are proportional to the 3/2 power of the major axis of their orbits. Okay, so T is proportional to R to the 3/2. That will be, this will be one of the equations that we will be needing, understanding paano nakuha ni Newton yung Universal Law of Gravitation. Okay. So paano niya sinulat yung Universal Law of Gravitation? Remember, you have your Principia, right? Your Principia has technically 2 volumes. The first volume has 2 books. The third volume has one book. The first two books, which is on book 1, which is the motion of bodies, tells about rectilinear motion and circular motion. That's the first book. So at the start of the first book, he stated the axioms or the laws of motion. Na-discuss natin to when we discuss our momentum. And then after that, he discussed centripetal force, V squared over R. Again, as I said in the optional discussion before, when you read your Principia, the Principia, it is like a geometry textbook rather than a physics textbook. Of course, there's still physics in the problems, especially in book 2 on the system of the world, but it looks really like a geometry textbook, which has some mathematical proofs, corollaries, and so on, lemmas, mga ganun siya. So yun, mukha siyang math book. Okay, the second book, book 2, is on the motion of bodies in resisting media. So here, he considered the fluids in motion, for example, and then after that, he also considered circular motion in fluids. Tapos, if I remember correctly, the relationship that the drag force is proportional to the square of the velocity of the object is written in book 2. Okay, we will not discuss book 2 here. Ang i-discuss natin, yung relationship ni book 1 kay book 3, which is on the system of the world. The system of the world contains what we now know as the Universal Law of Gravitation. Okay? So yon, book 1 is on Newtonian mechanics. Book 3 is on the system of the world, which is on Newton's Universal Law of Gravitation. Okay. Now, we have our heuristic argument here. A heuristic argument on how Newton obtained his Universal Law of Gravitation. Okay. Okay, so we have a heuristic argument here. A heuristic argument on how we obtained our Universal Law of Gravitation. Okay, paano? Okay, alam ni Newton from his book 1 that the centripetal force is mv squared over r. Okay? In general, for a circle, it's mv squared over r. Ngayon, what happened is this. So Newton has shown in his book 1 the idea of circular motion. It's actually proposition 4, theorem 4 of the universal law of the Principia, book 1. The centripetal forces of bodies which by equable motions describe different circles tend to the centers of the same circles and are to each other as the squares of the arcs described in equal times divide respectively by the radii of the circles. So that's 2 pi r over t basically. So yon, pinakita niya yan using a geometric proof. So hindi ko na papakita yung proof kasi sobrang dami niyan. But that's basically your heuristic argument. Ngayon, ang tanong ngayon, as a consequence, may mga corollary tong proposition 4. You have I will just show you corollary 6 and corollary 7. So the corollary 6 states that hence, if the periodic times are at the 3/2 power of the radii, and therefore the velocity is inversely as the square roots of the radii, the centripetal forces will be inversely as the squares of the radii, and conversely, and universally, if the periodic time is any power r to the n of the radius r, and therefore the velocity inversely as the power r to the n minus 1 of the radius, the centripetal force will be inversely as the power r to the 2n minus 1 of the radius, and conversely. So, ibig sabihin, if and only if statement yan. Okay, of course, ang tanong, ano ibig sabihin niya dito? Parang napakalalim, di ba, ng English. Pero ito lang ibig sabihin niya. So, Kepler and Newton. So, in equation form, F is mv squared over r. We know that. Alam natin yan. However, the velocity is related to the period. Diba? Remember, v is 2 pi r over t. Remember your circular motion before? Diba? V is 2 pi r over 2. And one can show, since v equals 2 pi r over t for circular motion, if t is the period of the orbit, then you have v equals 2 pi r over t. And you can substitute it on this relationship fc and say that, okay, I have an fc is 4 pi squared r over t squared. So, ito yung sinasabi no proposition for theorem 4. Yun lang yun. 4 pi squared t. That is, if the centripetal force is directly proportional to the radius and inversely proportional to the square of the times or the square of the period. Ngayon, may condition ka. What if the period is related to the radius? Ano mangyayari? There are different cases depending on the corollary, iba-ibang cases yung kinonsider niya. Now, balik tayo kay corollary 6 and 7. Kay corollary 6 especially, pag daw ang period ay 3 to the 3/2 r to the 3/2, if t squared is r cubed, then ano mangyayari dito? What happened here is this. If t, by Kepler's third law, which what Kepler's third law says. Remember, Kepler's third law is is an empirical law. And from the data by Kepler, t squared is cr cubed. Okay? By Kepler's third law, t squared is cr cubed. You can substitute here where if c is some constant, and substituting here, we get this relationship here. That is the force, the centripetal force, is inversely proportional to the square of the distance. Ito na yung hinahanap natin. F is proportional to 1 over r squared. And therefore, you have your universal law of gravitation. Ganon basically yung argument ni Newton. That's basically in a nutshell. Of course, may tanong, kaya sir, di ba elliptical yung orbits dyan? Now, he also shown in his in other parts of his work na may mga errors na hindi yan necessarily 1 over r squared. But the errors are small and therefore, we can think of these as other forces that are acting on the body and hence, in general, that's 1 over r squared. Okay? And of course, circular motion to. Kaya this is just in a nutshell. Kasi in general, this should be the semi-major axis of an ellipse, not the radius of a circle. Okay? Now, sir, totoo ba yan yung pinagsasabi mo? Apparently, the bottom line is you use an empirical law to generalize the force relation. This is an empirical law based on observation, and pinakita niya na for planets this is true, for the Jupiter this is true, for the Saturn this is true, for the Moon this is true, and it turns out that so here are your propositions for the system of the world, and proposition 6 states that all bodies gravitate towards every planet because pare-parehas yung nagiging conclusion niya for different planets. Like for example, the moons of Jupiter and Jupiter, the moons of Saturn and Saturn, the Earth's moon and the moon, of course, the Earth's moon and the Earth pala, and para-para yung naging conclusion niya doon. Okay? That there is a power of gravity pertaining to all bodies proportional to the several quantities of matter which they contain. This first statement here is basically the force is proportional to the masses, or to the masses M1 and M2. And then the second is just proposition 8, theorem 8, in two spheres gravitating each towards the other, if the matter in places on all sides round about and equidistant from the center is similar, the weight of each of either sphere towards the other will be inversely as the square of the distance between their centers. That is, the force is proportional to 1 over r squared. So these are all statements. May mga proof yan. Mahaba actually yung proof na itong proposition 7. Yung rational, bakit yung sinabi yan? Meron ba siyang explanation on other bodies? Kasi what we only considered here is the planets. Pero what if there's an ordinary object? And he has an explanation kung bakit totoo yan. Okay? Hence, by using very simple arguments, relatively simple arguments, and the brilliance of Newton, we have shown that it is indeed 1 over r squared because of Kepler's data. The empirical law gave a universal law. Malinaw? Malinaw ba to? Is this clear? Now, of course, the question is, anong significance? Ano naman ngayon? So what? What's really the point of this idea? Diba? It's actually, what's the big deal? Time natin, hindi yan big deal. Time natin ngayon, sinasolve nyo nga lang sa Physics 71 yan. But before, it is revolutionary. Bakit? Bakit naging revolutionary? Because, remember, the dogma is that the motion of the bodies, of the heavenly bodies, is not the same as the motion in the earth. In fact, di ba nga na-house arrest pa nga si Galileo nung time na yan by just contradicting the church teachings of a geocentric model of the universe because of his results in his telescopes. Di ba? So, the big deal, it's big deal because this equation here can be used to any object with mass and therefore can be used to identify the motion of these objects. Any object, including the motion of heavenly bodies. They are united by a single equation. Yun yung importansya ng Newtonian mechanics. That is, you can use now just simple equation here to predict the motion of these bodies. Of course, sir, sir, di ba hindi naman laging totoo na mapapredict mo? Depende kung exactly mo malalaman. Of course, kung approximate yan, hindi yan laging an approximate present will not necessarily predict an approximate future. Kaya may tinatawag na chaotic motion, di ba? May tinatawag na dynamical or tawag dito? May chaos sa tinatawag. Deterministic chaos sa tinatawag. Yun pala yung term nila doon. So, the point here is it gave a different perspective on how the universe works. Because Newton has shown that it is indeed just using a simple equation, you can use, not necessarily, it's not actually a simple equation. But yeah, it's just a single equation that can determine the motion of bodies that are seemingly not the same, di ba? So, in principle, kinematic equations can be obtained. Again, you remember your kinematic equations, your position, velocity, and acceleration can be determined from this equation of motion here. This is an equation of motion. Medyo complicated lang kasi may position dependence ka sa equation of motion. Okay, then we can determine the motion of any body with mass throughout the universe. At least in the time of Newton. Yun yung makukuha natin. It's a mechanistic universe. So, okay? It's a mechanistic, it is a deterministic universe. Hindi na tayo tumitingin sa mysticism, dun sa misteryo ng mga planeta o ng mga heavenly bodies. Meron na tayo ngayong equation na makakapag-predict dun sa motion ng mga bodies. Diba? Ang ganda-ganda. Okay. And then, ang tawag dyan ay therefore Newtonian synthesis. Kaya siya tinawag na Newtonian synthesis because it's a synthesis of all the equations that you have. Your Newtonian Newton's laws of motion and then your Newton's universal law of gravitation, which explained the behavior of the planets or the behavior of the motion of the planets and all other bodies with mass. Diba? So with a few laws, just 4, 3 laws of motion, universal law of gravitation, and the rest are just consequences of these 4. You can explain phenomena that are seemingly unrelated, like for example, the motion of falling bodies, and the motion of projectiles, and the motion of planetary, and the motion of planets. Kala mo magkakaiba yan, pero actually, they are united by a single equation. That's why you have a synthesis. Okay? Malinaw? Malinaw to. I hope this is clear. And finally, the universe is therefore mechanical. Nawala yung mysticism ng universe. And it gives you a new perspective na mechanical naman pala ang universe, na hindi naman pala siya pulong-pulo ng misteryo. You use your mathematical principles, you use your equations to predict the motion of objects, to predict what will happen to the objects next. The future motions of all objects can be predicted if we exactly, the keyword here is exactly, if we know exactly the initial position and velocity of one object, and how it will act on another mass. If we know it that exactly, we can determine at any given point in time the motion of that object. But in practice, hindi natin necessarily alam exactly yan. Kaya the approximate path does not necessarily predict the approximate feature. That's why you have deterministic chaos, for example. Di mo nga masolve ang three-body problem eh. Okay? So yun yung sinasabi about mechanical universe. And a more philosophical perspective is because the universe is mechanical, the universe has become rational. You have a rational universe. And you can now explain complicated phenomena using simple laws. So very simple laws, like Newton's law. Diba? And hence, the universe is a rational system governed by simple rules. Meron kang rational system ng universe, it follows your GMM over R squared, and therefore you can predict the motions of them. Hindi na siya misteryo ngayon. Hindi na siya nakakatakot. Okay? And this thinking gave you some ideas. It's related to our thinking of the state and other revolutions in the Europe that time, which is your scientific and intellectual revolution. Ang laki ng contribution niyan ng Newtonian mechanics sa idea na indeed the universe is rational and is mechanical. Okay? But of course, through time, pag-uusapan nyo sa Physics 73 na okay, hindi yan totoo lagi. There are some issues of Newtonian mechanics in general. But at least when in our case, ang importante dito is the notion of planets at least can still be discussed or can still be modeled using Newtonian mechanics, which is really interesting. Okay? Are there any questions for this topic? May tanong ba? So, in summary,